Hello, everybody that's on. This is Tadas Lewis with Sage Environmental. Got a number of folks that we see are still logging in, so we're going to hang on just a couple of minutes to get started so we can try and get everybody, or as many as possible, logged on. All right, this is Tadas Lewis again with Sage. I've got 11 o'clock Mountain, 12 o'clock Central on my time, and so we want to get started, even though I see some folks are still joining the GoToMeeting. I want to try and keep to our time schedule. First off, just want to say good afternoon and thank you for joining us for today for Sage's sound off regarding the recently finalized refinery sector risk, technology review, and new source performance standards. For any of you that I haven't had the opportunity to meet, my name is Tadas Lewis. I work for Sage Environmental Consulting out of our Denver, Colorado office. Additionally, presenting this information with me today is Mr. Blake Yarborough out of Sage's Beaumont, Texas office. And rather than spending 5 minutes giving everybody a list of our accomplishments and experience, we thought we'd just spend the time focusing on these new regulatory requirements. That said, Blake and I are a couple of the senior folks at Sage that are neck deep in this rule and how it's going to impact all of our refinery clients. To get things started, I wanted to give a brief overview of how this presentation has been structured. We're going to begin by providing a big picture overview of the final rule. Following that, we'll walk through a summary of the changes, the most recent changes between the proposed and final rule. And after that, Blake Yarborough will provide us with a much more detailed presentation and information regarding the final rule requirements, including all of those new changes. To conclude the presentation, we will focus on the capital cost impacts that are associated with this rule. As we know, refinery management is going to want to know immediately how everybody needs to budget for this rule over the next few years. One last thing before we get started here, for those of you that have joined this GoToWebinar from your computer, we will be able to field questions at the end of the presentation. In order to do that, you will just need to type in your question into the box that's listed as questions. For those of you that do not have or are not logged in through your computer, contact information you can find for Blake and I on Sage's website, or you can just email me directly. It's Taras, T-A-R-A-S, at sageenvironmental.com. All right, without further ado, we're going to jump into this presentation here. And as I said, feel free to ask your questions, send them through that comment or question box at any time. You don't need to wait till the end to do that. All right, as an overview of the final rule, so on September 29th, one day early, I guess, the EPA issued this final rule for us. It's going to require emission control, additional emission controls for storage tanks, flares, and delayed coking units. We also know that we're going to have to monitor the air concentrations at the fence line to ensure that the proposed standards are being met for benzene. The third bullet here, we show we're eliminating the exemptions to emission limits during periods of startup, shutdown, and malfunction, which is going to cause some additional work and quite a bit of headache is the way I see it. Fourth bullet down, we see we now have the work practice standards for atmospheric pressure relief devices, or PRDs. Now we'll go through those in some more detail, and then additionally there were some technical corrections and clarifications to the Nsps that came out as a result of this rulemaking as well. And there at the bottom, if you're looking at it on the screen, you can see there's a link to EPA's website containing all the information regarding this. Okay, getting into a little more detail, the final amendments to the NESHAP and Nsps are effective 60 days after publication in the Federal Register. Now, we have not seen this come out in the Federal Register yet, but we are expecting it any day. But the draft rule, or the rule that was signed by the EPA administrator, is what's available to us right now. We expect that to be the exact same thing that comes out in the Federal Register. Okay, for new sources, they're going to need to comply by the effective date of the final rule or upon startup of that new source, whichever of those dates fall later. Now, for existing sources, here's what we're looking at in terms of compliance dates. For delayed coking units and catalytic reforming units, those requirements are going to be 3 years after the effective date. So what we're looking at is December of 2018. Flares, similarly, have a 3-year implementation period, due date of December of 2018. For fence line monitoring, the final rule took a year away from us in terms of implementation. So those requirements now have 2 years after the effective date. So we're looking at December of 2017. For refineries which have marine vessel loading, that effective date is going to be the final date of the, effective date of the final rule. So 60 days after we see it in the Federal Register, which should be December of 2015. For the FCCU requirements, those will be 18 months after the effective date. So we're looking at June of next year for all of those different requirements, specifically stack testing for PM and HCN. For the SSM provisions, those will be in effect at the effective date of the final rule. So that's December of this year, unfortunately. Now, for the atmospheric PRDs, we're looking at 3 years. So again, December of 2018, and for storage vessels, this one is a little sooner. It's 90 days after the effective date. So really what we're looking at is March of 2016.
It's Ross, this is Blake. Just to clarify, we have 6 of 2016 for the FCCU. That's 6 of 2017, 18 months.
Ah, perfect. Thank you. Okay, now for the summary of changes between the proposed and the final rule. From a PR perspective, the emission reductions were lowered in this final rule. What we're now looking at is, or at least what EPA has published, is an anticipated reduction of 5,200 tons per year of air toxics that will be reduced, and 50,000 tons per year.
Stuff. Is there anything you can do to improve that?
Hey,
Like
hold
how
on.
the president is?
Hold on, Ramona, can you hear me?
We have to improve that.
Ramona, I can hear you. If you can mute yourself, that'd be great.
Thank you.
And there was an anticipated reduction of 50,000 tons per year of volatile organic compounds. That change was mainly due to the revised emission factors for cokers. On the risk assessment side, there was a sensitivity analysis that was also conducted as part of this. And what EPA has publicized is a 15 to 20% reduction in cancer incidence associated with this rulemaking. Okay, now getting into the technical details. So for flare combustion efficiency, what we now have in the final rule is a single net heating value operating limit in the flare combustion zone. So instead of the multiple ones we were looking at, it's a single value greater than or equal to 270 BTU per standard cubic feet in that combustion zone. Additionally, EPA did allow the use of the higher adjusted hydrogen heating value, 1212 BTU per scuff, if there is a system to monitor that hydrogen. Also, we can choose either a 15-minute feed forward or a 15-minute block average to demonstrate compliance for the flares as well. Additionally, what was finalized was a limited sampling provisions are allowed to demonstrate compliance for flares that have non-variable flare gas compositions. For delayed cokers, we're allowed to meet the 2 psig across the coke drums within all existing delayed coking units at the facility. The important part here is for existing delayed coking units, we're allowed to use a rolling 60 event average limit basis to meet that 2 psig across all of the coke drums. Now for new sources, any new delayed coking units, the MACT floor was set of 2 psig on a per coking cycle basis. So for those, we do not have the option for the facility-wide averaging. It's specifically just a per coke cycle basis. And last, on the coking units, they revised the refinery emission factors and costs based on additional info received. As I mentioned, for fence line monitoring, we reduced the implementation time from 3 years after promulgation to 2 years. And there was also additional specifications for alternative monitoring technologies provided. EPA gave us some clarification on monitor siting and the analytical procedures to be used, as well as an option for less monitoring or sample locations that consistently remain below 10% of the fence line benzene concentration trigger. This does require reporting now on a quarterly rather than a semi-annual basis, and it's still to be determined how EPA is going to communicate the results of this monitoring to the public. So that'll be interesting to see how that unfolds. EPA discussed that they want input on how this should be communicated to the public. For storage tanks, with the EPA has finalized option 2 of the June 2014 proposal. What that requires is guide pole controls and other fitting controls for the existing external or internal floating roof tanks. And this is these requirements are structured based on the generic MACT for storage vessels, which comes from 40 CFR 63 subpart WW. Additionally, they've revised the definition of Group 1 storage vessels to include smaller capacity vessels and storage tanks containing materials with lower vapor pressures. So essentially encompassing a greater group of storage tanks into that Group 1 category. The rule also has the elimination of our malfunction exemptions. Work practice standards have now been established for pressure relief devices and emergency flaring. This includes proactive requirements, better controls on the process, instrumentation, operator training, staged relief, and then also will require changes in operations and practices rather than building more flares to control releases. Essentially, they said we don't want more flares, we just want better control of our malfunction emissions. And then last here we got marine loading. For any of you that have marine loading, they amended 40 CFR 63 subpart Y to remove the exclusion for marine vessel loading operations at refineries. So small marine vessel loading and offshore marine vessel loading is going to be required to use submerged filling. And again, that is at the time of the rule is finalized, so 60 days after we see it in the Federal Register. Okay, so with these amendments, not only did they affect the MAC standards, they also affected NSPS J and JA. This slide focuses on the amendments for FCCUs. So for the CATs, what we see is we've removed the incremental PM limit when we're burning liquid or solid fuels. Now we also have a 20% opacity limit on a 3-hour average. So the 30% doesn't exist anymore, it's now 20%. Additionally, for other control devices, operating limits, those are now on a 3-hour average for the CATs. Previously, those were a 24-hour basis, so we lost some time there. For CO boilers, it was specified that the fuel gas must meet the fuel gas standards of NSPS J or JA. And then they added in bag leak detectors as an option to comms. So anybody that's got some sort of fabric filter control on their CAT and using we can use bag leak detectors as opposed to comms specifically. We also incorporated the total power and the secondary current operating limits for CAT ESPs, and requiring daily checks of the air or water pressure to the spray nozzles on jet ejector type wet scrubbers. Other types of wet scrubbers or other types of scrubbers that have the atomizing spray nozzles as well. Last bullets on this slide that are important. So performance testing for PM is now going to be required every 5 years. It's no longer a one-time requirement. And it will be required annually if we are within 80% of the PM limit. So 0.8 pounds per 1,000 pounds of PM per 1,000 pounds of coke burn will require annual testing. We also will do have a one-time HCN performance test requirement for anybody that hasn't already done their CAT HCN testing or plans to do that. Last amendments here to J&J, the sulfur recovery plants, they provided some emission limits for the different types of SRUs based on oxygen enrichment. They fixed some of their equations, clarified terms, and fixed the monitoring requirements in there for sulfur recovery plants. For SRUs that are subject to NSPS JA with a capacity greater than 20 long tons per day, they can comply with NSPS JA as a means of complying with MAC TRIPLE-U. And additionally, they did clarify some requirements for stain tubes in these last amendments. With that, I'm going to turn control over here to Blake to go through a little bit more detail on some of these things. Blake, can you grab control here?
Yeah, looks like I've got it here. Thanks, Ross. So just a reminder, we're taking these questions and logging them, and that are coming in, so we haven't skipped you. We see those questions. We will address those at the end towards the question and answer section as best we can. So some of the final rule requirements, some of the first things that hit on with storage vessels. So it requires an upgrade of some of the controls and the lower applicability thresholds. So the roof deck fittings and inspection requirements, you've got to have gasketed covers for roof openings, ladder wells, access hatches, etc. And then the sleeve and wipers for guide poles. And then there's a revised definition for Group 1 storage vessels, as Ross hit on, and that requirement is that you've got to control tanks greater than 20,000 gallons with a vapor pressure, true vapor pressure of greater than 1 psi, or 40,000 gallons with a true vapor pressure greater than 0.7 psi. And then there's a reference to Part 63, Subpart WW and SS, which are the standard. All right, so for flares, we've got quite a bit that went on for flares here. It removed cross references with 6311, and then will operate with a pilot flame at all times, regulated material ascent to the flare, and it's 1 minute with no pilot flame, and a 15-minute period is a deviation. And then did not require the proposed automatic reignition capability for flares, but you must continuously monitor for pilot presence. And then you've got to specify the smokeless design capacity and operate with no visible emissions. That's what VE is there. It allows for 5 minutes in any 2-hour period when regulated material sent to the flare and below smokeless design capacity. And then you can have 1 5-minute per day method 22. And then if visible emissions are observed, you must perform a 5-minute method 22 and continue for 2 hours if the visible emissions are observed for more than 1 continuous minute. and then it added the capability to use video monitoring in lieu of method 22 determinations. So we've got some more flare tip exit velocity requirements. When regulated material is sent to the flare for at least 15 minutes and less than the smokeless design capacity, you've got to operate at less than 60 feet per second, or the calculated Vmax less than the Vmax. And then combustion zone operating limits, the net heating zone combustion value has to be greater than 270 BTUs per scuff on a 15-minute block average period. And then the gas must be routed to the flare for at least 15 minutes. They didn't finalize any lower flammability limits or combustion zone content parameters. And then this includes the ability to utilize the 1212 BTUs per scuff for hydrogen. So some more on flares. The dilution operating limits for the flares with perimeter assist air. The net heating zone value with dilution has to be greater than 22 BTUs per cubic foot on a 15-minute block average period, and the gas must be routed to the flare for at least 15 minutes. And then you've got to monitor the composition of the flare vent gas or directly monitor the net heating value, and the potential for separate hydrogen monitoring. So you need a measurement at least once every 15 minutes. You can utilize a grab sample every 8 hours, or you can do direct monitoring. It's not required for purchased pipeline quality natural gas streams or streams determined to be consistent in composition. And that can utilize a feed-forward method or a direct calculation method. So some more on flares. There's a requirement to install a volumetric flow rate monitor on the flare header as well as any supplemental natural gas used. So by installing the volumetric flow rate monitor on assist air or assist steam, you need to separate the monitoring for premix and perimeter assist air, and then you can use a fan speed or a power fan. You can use the curves for that. Must correct for temperature and pressure to standard conditions, so 68 degrees F and 1 atmosphere. And then mass flow meters can be used, but there are some caveats to when they can be used. And then pressure and temperature monitoring with engineering calculations can be used. And then the accuracy requirements for Nsps JA and max CC were made consistent across the consent decrees. So 20% between 0.1 to 1 foot per second and 5% above 1 foot per second. So under the emergency flaring provisions, you're operating above the smokeless capacity. You have to develop a flare management plan very similar to the FMPs required for Nsps JA that is due next month. The root cause analysis and corrective action requirements when flow rate exceeds the smokeless capacity. So the visible emissions is what would require this is visible emissions present for more than 5 minutes in a 2-hour period, or you have a 15-minute block average flare tip velocity that exceeds the maximum flare tip velocity. And then there is an alternative mean of emission limitation and a CPMS monitoring plan. So we'll jump over to a couple of the other sources. Flares did take up a major portion of that. But under delayed cokers, they do not allow emissions to the atmosphere from the steam vent until the drum pressure is below 2 PSI. They did allow averaging to meet the 2 PSI across existing coke drums at a facility. That is, again, on the 60 event average limit basis. The new source MAC floor will be 2, so any new cokers will have to be below 2 PSI. And there's no facility-wide coke drum averaging period. And then the revised refinery emission factors and costs are based on the additional info that was received during the ICR. And then the catalytic reforming unit vents, so vessel pressure limit exclusion of 5 PSI to apply only to passive depressurization. And then their active purging of the CRU will need to meet the emission limitations in Table 15 and 16 in subpart UU at all times regardless of pressure. So the fence line monitoring was probably one of the most commented on sections of this rule. I would say that EPA did look into some of the comments and use disagree a lot with a lot of the comments, but we'll go through what some of the requirements are. So you have to deploy passive monitors surrounding the refinery at the fence line. Use a 2-week average concentration reading, calculate the annual average benzene concentration, and compare that against an action level, which is 9 micrograms per cubic meter. You have to conduct a root cause analysis and corrective action upon exceedances of the action level. And then there's the proposed EPA methods 325A and 325B, which are carbon-based sorbent tubes with diffusion caps. They'll be placed 1.5 to 2 meters above grade. The weather protection required. They can be used with a radial or linear approach, and then additional sample tubes will be placed in within 50 meters of a fence line for known VOC sources. So examples are wastewater treatment units, tank farms, etc. So the primary requirement for the monitoring system is that it provides adequate spatial coverage for the determination of representative pollutant concentrations at the boundary or the facility of operation. A proposed monitoring program would require the monitors be placed 15 to 30 degree intervals along the perimeter of the refinery depending upon the size. So that EPA has kind of broken down what is small, medium, and large facilities. So they consider a small facility less than 750 acres, which would roughly equate to about 12 locations for monitoring. And then a medium facility somewhere 750 to 1,500 acres should be placed at 20 degree intervals, which equates to about 18 locations around the facility. And then large facilities greater than 1,500 acres, the monitors should be placed at 15 degree intervals, accounting for roughly 24 locations. So the monitors can be placed every 2,000 feet along the fence line, alternatively, of the refinery, which may be easier to implement, especially for irregularly shaped facilities. So I know when there were some pilot studies done, it was hard to distinguish where exactly to place monitors, so this is where this alternative siting procedure comes in. So before I jump into the startup and shutdown malfunction, the fence line monitoring, as we've talked about, does take into equation the fact that you can reduce the monitoring based on how long it's been since you've had an action level hit. And so it's roughly every 2 years you get to begin skipping cycles. So if you go 2 years through with no hits above the action level, you get to skip every other period. And then if you go 2 more years, you end up in quarterly. So you're only doing 1 sample per quarter. If you go another 2 years with no hits, you end up in semi-annual. And then if you go another 2 years beyond that, you end with no hits, you end up in just an annual sample. It's a 1 2-week sample, but at any time during that sampling, if you get a hit above the action level for 1 month, you have to go back to the contiguous 14 days, and then there's some language in there that if you get a hit on the continuous, the 14 not within the month, if you get no hits within the month, you go back to your regular routine sample with the spacing that you were at previously, and if you get a hit, you end up back in the contiguous 14-day sample for 2 years before you can start working your way through the monitoring requirements again. So we'll jump into the startup, shutdown, and malfunction. Remove the SSM exemptions and add limits for certain sources during startup and shutdown. So FCCU, you get 1% minimum oxygen limit during startup and shutdown, and the minimum cyclone face velocity limit during startup and shutdown. And then sulfur recovery plants, there's an alternative SRP incinerator temperature and an excess oxygen limits during startup and shutdown. So bypasses and discharges through pressure relief devices are a violation of the standard, and requirements to monitor discharges via direct monitoring or monitoring of operating conditions. So this will require preventative measures as well as an RCA and a CA, which root cause analysis and corrective action there. So equipment each PRD and organic HAP service with a device or uses a monitoring system that is capable of identifying the pressure release, recording the time and duration of each pressure release, and then notifying operators immediately that a pressure release is occurring. And so that footnote there is that new affected sources are required to route all atmospheric PRDs via a closed vent system to a control device, but that requires that the new units being built have more than 25 tons of HAP total or 10 tons of one HAP, so they have to be a new major source in and of itself. So That doesn't mean that if you build new units within a refinery and you don't trigger 25 tons per year of total HAPs or 10 tons per year of one speciated HAP that you would necessarily have to route everything to a closed vent system. You could fall into the work practices. So the minimum of 3 redundant measures to prevent atmospheric releases, or you can install a closed vent system and route to a flare, drain, or other control system. So examples of preventative measures include flow temperature level and pressure indicators with dead man switches, monitors, or automatic actuators, documented routine inspection and maintenance programs, inherently safer design or safety instrumentation systems, deluge systems, and then staged relief system where initial pressure relief valve with a lower set release pressure discharges to the flare or other closed vent system and a control device, so you can stage, what 2 psi, 4 psi, for example, which relief valves would go to the flare and then what would go to atmosphere. And then root cause analysis conducted on all release events for each PRD. So there are some exempted PRDs in the rule. Some of these is the potential to emit less than 72 pounds per day. The design release pressure is less than 2.5 psi. The PRD is in heavy liquid service. It is a thermal expansion relief valve, or the liquid PRD hard pipe to controlled process drains. And then if the PRD is located on mobile equipment. So violations of the work practice standard would, root cause was found to be operator error negligence. That would be a violation. If you have 2 release events in a 3-year period, not including a force majeure, of the same PRD, if the root cause is the same, would be a violation. And then if you have 3 release events in a 3-year period, not including force majeure again, of the same PRD, even if the root causes are different. All right, with that, I'm going to hand it back off to Taras for some of the capital cost discussion.
All right, thanks, Blake. So kind of concluding this presentation, we just hit you with a lot of technical details. Now what we wanted to focus on is, hey, okay, what's the capital cost impacts that are associated with this? Really because we know refinery management wants to know budgets, and they want to know it now for the next 3 years, and so we need to do some digging in order to figure out on a refinery specific basis what the true costs of this are actually going to be. So from EPA's perspective, they estimated the final rule is going to be about $283 million for all of refineries. 112 million from the final amendments, and then 171 million from the standards to ensure continuous compliance with them. EPA estimated the annual cost to be about 63 million, and that includes 11 million credit for recovery of lost product that they are saying we're going to get with this regulation. Now, our estimates are much greater than those that EPA has prepared, so we've got to take that with somewhat of a grain of salt. We can't necessarily pass that on as gospel to refinery management, but what this does give us is at least an idea of what are going to be the most costly provisions associated with this rule. So on this slide, what we're looking at is what part of the rule is going to take the most capital to comply with. I need to specify that this is going to be refinery specific and is definitely going to be dependent on your current refinery operations and controls. But EPA estimates for flares, we're looking at a total capital cost of $160 million. Annualized, that's $46.5 million a year. For cokers, $81 million, total capital cost, and an annualized cost of $11.7 million. Storage vessels are the next highest at $18.5 million total capital. And then that's actually showing we're going to get a payback by EPA's calculation in terms of product recovered on the annualized basis. For the fence line, total capital of $12.5 million, which is annualized at $6.36 million. The relief valve monitoring, $11.1 million, which is annualized for $3.3 million. And the CAT testing, we didn't look at the capital cost, they just looked at the annualized cost of $0.4 million a year. So specifically what we want to highlight here are the most expensive ones. What makes sense to us here is this is the sources we would focus on first in order to determine where we're at in our compliance stage and how much money it's going to take for us to get into compliance and stay in compliance with the rule. For flares, it's a variable, depending on your refinery, it's going to be, you're going to be in a different place for compliance depending on what controls you already have in place on flares. Some folks that have entered flare consent decrees are going to be farther along the path than those that have not implemented any of the additional controls that we've seen required by the CDs. So what we really see is the first project everyone's going to have to undertake with this is doing a detailed breakdown source by source or source by affected source to figure out what that cost is going to be to the specific refinery itself. We've had some folks actually already go down that path, so getting those detailed cost estimates is a little bit of effort, but definitely worthwhile, especially when we need to report to management what we're gonna need to spend for this. Delayed coking units are next at a cost of $81 million. This is estimated from EPA for folks that will have to install additional equipment in order to get down to that 2 psig before venting. Now, EPA gave us, one of their options that they looked at in terms of engineering, but I'm not sure that they did a detailed enough analysis that 81 million makes, at least doesn't give me a very comfortable feeling that that's actually going to be realized at refineries. I think it could be potentially much more than that. And then last is storage vessels, where we need to figure out, okay, what controls are in place on our current floating roof Group 1 tanks, see what controls need to be installed in order to comply with those, and then also which of our new tanks are going to get pulled in as Group 1, now requiring controls that haven't been there before. Again, EPA estimates that at 18.5 million. I don't know how they came up with that without knowing detailed fittings for every single storage tank out there, but really that's what we're going to need to do in order to figure out what that cost is specifically to each of our refineries. All right, so this last slide just provides contact information for myself as well as for Blake. For those of you that may not be on your computers, the best way to reach Blake or I is on cell phones or via email. Quickly, my cell phone is 215-990-4989. And again, it's TARAS@sageenvironmental.com. Blake Yarbrough's cell phone is 832-374-1309. And his email is Blake, BLAKE, .Yarbrough, YARBROUGH, @sageenvironmental.com. All right. Now with that, I know we've got a couple of questions that have come in. Just wanted to make sure that if you can't see, or if you are on your computer, within the GoToWebinar window, you should be able to see a questions box. If you wanted to add your question there, feel free to put it in. Give me 1 minute while I switch to be able to access those questions. Okay. Very important question. So, okay, can these slides be made available? Yes, they can. If you just email myself or Blake, we'll be sure to get you a copy of those. All right. Scrolling through, I'm just going to pick some of these questions at random. Here's one. This is actually a good point. So rather than a question, it's just a observation clarification. It says for the CAT testing, I wanted to note that EPA has indicated there's a desire to conduct the testing of the CATs such that it includes soot blowing. That's a good point because we haven't necessarily always been doing those tests during the soot blowing. Okay. Blake, I see some fence line questions. Did you want to take one of those?
Yeah. Let me see what I've got here. So one question here is, has there been any guidance on how to handle fence line monitoring of a non-contiguous part of a refinery, i.e. standalone tank fields? There's quite a bit of discussion in the question and responses by EPA to that. I believe that the way that they tried to address that is by the alternative means, and saying that you could do it by the every 2,000 feet along a fence line, because sometimes you end up with a lot of stations if you use the radial method there. Yeah, the best guidance I've got is that there's a lot of discussion in the questions about how to handle that and some of the alternatives that you can look at.
All right. I've got a question here on what was the basis for the cost estimates for the delayed coking changes. So all of those cost estimates come directly from EPA. So none of that is specific to any refineries that I'm aware of. Now, I'm going to back up a few slides here. So specifically for the delayed coking units, what EPA said is, okay, so we want the coke drums depressured to a closed blowdown system until the coke drum pressure is at 2 psig. Now, what they've said is that EPA says is that this will be accomplished by installing and operating steam ejector systems to reduce the coke drum pressure prior to venting. So their cost estimate said for a certain percentage of refineries, they're going to need to install some sort of steam injector system to get down to that 2 psig. I don't know exactly how they got that number, and that's why I said I don't feel perfectly comfortable with that 81 million that they came up with. Additionally, beyond steam ejector systems, EPA said, okay, we might need some additional engineering in order to get down on another percentage of these cokers, and so that added an additional cost beyond just the steam injectors. But again, I just don't feel comfortable with how they came up with that number, and so I really think there needs to be a refinery by refinery needs to specifically go through that and figure out what cost for that control is actually going to be for them. Okay, another question I've got here is, don't the SSM provisions only become effective on the final date of the rule for MAC-UUU sources? That is correct. So going back, one too many. So the SSM provisions, as you can see, have an effective date of the final rule. So that's going to be 60 days after publication in the Federal Register. So that's going to be December of 2015. Okay. Scrolling through some others here. Question I've got here is, do we have a definition from EPA as far as using force majeure. Now, I don't have the answer to that question. That's a good question, because I've been through a scenario involving force majeure, but I've never seen it explicitly, well, not seen it well defined in terms of implementation. Blake, have you seen anything on that?
There's some discussion in the stack testing guidance document about what the force majeure would be there. That's the only place I've ever seen it really discussed in terms that you might be able to apply to what you're looking at for being able to use that. So I see a couple more. There's quite a few fence line questions, and one is there an allowance for upwind background discounting of the downwind air monitoring values? There is. You have to do an alternative monitoring plan. It's not necessarily an AMP, but what you send in is you've got to write up, why that value is what it is, whether there's a downwind source that would contribute to that, whether it be an on-site source or if it would be a neighboring facility, and then that has to actually be approved by the administrator to be able to use that background level that would be included in all of your samples.
All right. I've got a question here. It says, do you know what the cost per gallon of gasoline these changes will add? Again, I think that's a great question, and I would love to be involved with doing a detailed analysis to determine that. EPA's response is they do not expect this to significantly change the cost of gasoline. They've put that in their responses to comments. Whether that's reality or not, we will see.
Yeah, I see another question. Will fence line monitors have allowed outage times? The way the rule is written with the passive monitoring, there is no allowance for outage times. If you're using some type of FTIR or UV-DOAS technology that may already be in existence, I would think that an AMP would have to be written such that it might allow for some downtime if that already is existing in the consent decree or something like that. But if you're just complying with passive monitors, there is no allowance for outage times.
Okay.
I see another good one for us. We've recently conducted an HCN test for FCCU in 2014. Prior to the final rule, will we have to conduct an additional test to comply with the new rule? I think in a lot of cases that'll be up to where the authority is delegated. I've seen TCEQ, for instance, use a historical stack test that would be within the window if it was representative for compliance, but I'm not sure from state to state how that is handled.
Okay, I got a question here on the feed forward term as it's used regarding the flares and what that means specifically. So what I've got here, I pulled up the actual the rule, and what we've got here is a definition. In other words, it says, quote, feed forward refers to the fact that the rule requires the refinery owners or operators to use the net heating value of the vent gas going into the flare in one 15-minute period to adjust the assist media, the steam or the air, and or the supplemental gas in the next 15-minute period as necessary. For the equation in the rule, so basically the feed forward is for one 15-minute period, you adjust the steam or the air, and in the next 15-minute period, the supplemental gas as needed to make sure you're meeting that 270 BTU per standard cubic feet net heating value limit. and it looks like I got another question here for delayed cokers. The question is the coker pressure limit 2 psi or less than 2 psi? So 2 psi is the limit itself. So it should be below 2 psi. And that's equal to or less than 2 psi, and that's psig. I just want to make sure I specify pounds per square inch on the gauge.
I see a question, is the $283 million estimate per refinery? That's actually what EPA's estimate was for across industry. That's not per refinery.
Yeah, and that again we feel is very much underestimated.
I believe AFPM has actually put that number possibly above $1 billion.
Right. Okay, then I've got another question here for the FCCU requirements that we had touched on. The question is, are these changes to MAC triple U or to NSPS JA? The answer is it's actually both. So there's some MAC triple U changes, and then in order to make sure that that the rule agreed with when it references J or JA, they made changes to J and JA as well. So this changes MAC triple U, MAC CC, as well as J and NSPS J and JA. Yeah, and I got another clarification, so Blake caught it on our slide there as well. Implementation for the CAT testing is a 18-month window, so that's going to be June of 2017, not 2016 as I had in there. Again, I get a bunch of requests for the slides. We can definitely send them to you. Just contact either myself or Blake, and we'll be happy to get those over. Another comment here, similar to what Blake had mentioned for the force majeure. It says many of the consent decrees have their own definitions of force majeure, so that'd be a good place to start with if we're looking for a definition for us. That is, of course, assuming you are currently subject to a consent decree. All right, a little bit of a slowdown in questions coming.
So I'm seeing a comment here that's a good clarification that's in the rule that discusses requests to the administrator to use previous HCN test data, which that would address the question for we did it in 2014. Could we use that versus having to do it for the new rule?
And that said that was allowed, Blake?
Yes, 63-150 or 1571 A6I B through D discusses the request to the administrator.
Okay. Okay, so another one came in. Were there any changes in the Met station requirements? I did not see any, Blake. Did you see any for the fence line?
I did not see any.
That's a part I'm not sure if everybody caught originally, but some folks didn't realize they're going to have to put in new Met stations or a Met station if one hadn't existed previously for part of that fence line monitoring. Good point of clarification.
Yes, for the FCC HCN testing, does it specify the test methods that can be used, FTIR, etc.? I don't think there was any specific method that was called out there. It would just have to be an approved EPA method that would be capable of seeing HCN. So something like the method 25A would not be, even though it's a hydrocarbon, it wouldn't pick it up in the monitor in the SIMS there. So something like FTIR certainly could be used with the approved method.
Yeah, and then Blake, I don't even know the answer to this one, but it says under circumstances, can they utilize nearby Met stations if they're not specifically on the refinery property?
So I believe the rule actually says that you're supposed to have Met data for the site. There potentially maybe an AMP could be written such that if there's one neighboring or if there's already an ambient station that may sit at a just off site that would gather that data. I believe that may be usable, but within the 25 miles, that potentially if the Met station is an airport or National Weather Service station within 25 miles, you might be able to use that.
Okay. I guess my input just logistically would be, hey, I would love to have one on my site, especially if I'm near other sources and I'm getting hits. And if I somehow need that data in order to prove that it's not coming from my refinery, it might be coming from another refinery, I would certainly want to have that Met data at my facility.
Right. I know one of the questions I had been asked was, could we replace one of the passive monitors with like a GC on each, perimeter of the fence so that we could see real-time data? And I believe as the rule's written that you would have to request a modified sampling plan to do that. Mainly because of releasing it to the public, and the rule is written such that to use diffusive or to use the tube monitoring on the fence line. So if you deviate from that, it's going to take some type of written request and approval. But it certainly would help with why or where the hit is coming from. If you had the Met data on site and then you had some type of real-time monitor, it would certainly help you get to a root cause analysis quicker.
And Blake, I got another one here for you. So for the benzene fence line monitoring, are the boundary and the fence line the same? Question is that what if the property boundary includes some other areas that aren't necessarily within the fence line, but they own that land as well.
Right. So the fence line is defined as the means the property boundary of a facility or internal monitoring perimeter established in accordance with the requirements of this rule. So it could be the fence line if your fence line doesn't necessarily sit at the property boundary is the way that I read that, but it just means that you've got to have your monitoring stations set that they're representative of the air that is coming across the fence line.
All right. What else we got here? Okay. Do the fence line monitoring requirements apply to bulk terminal storage facilities? I'm guessing that question is if the bulk terminal storage facility is located nearby or at the refinery. Blake, correct me if I'm wrong, but if it's within the fence line of the refinery, then yeah, it's going to have to be included in that.
But within the fence line, yes. If it is physically separated, there is no requirement, I believe, to include it.
All right. Well, I have the clock now at 1 o'clock Central. We're going to take note of all these questions that we got that we didn't have a chance to address, and we'll make sure to follow up with everybody individually on those. If you do have any questions going forward, as I said, please feel free to reach out. We're neck deep in the rule as well, so happy to provide you with any input that we have on it, as well as experience that we have with some of our clients as everyone's going through this rule together. Again, thank you for joining us, and please feel free to reach out if you have any questions. Thank you all. Have a good afternoon.
Thanks, everybody.